Hello everyone, let's talk about ambiguous cases. So we're going to do law of sines and I'm going to show you all the things that can happen when you're doing a law of sines and you're given angle side side. Let me draw the picture. So you need to remember that when you draw the picture, if I call this angle A, then across from that has to be little a. This is angle B, this has to be little b, and across from angle C has to be little c. So the information they're giving me is angle A is 30 degrees, little a is 7, so I'm going to erase that and make that a 7, and little b is 16. So the reason I know that this is going to be something interesting is because they're giving me an angle side side. Angle side side is when you get into trouble and you got to be real careful because it's possible that either this is an impossible triangle or there's more than one answer. So what we're going to do is set up our proportion the way we always do. The sine of 30 over 7 is the sine of b over 16. And now I'm going to get the sine of b by itself by undoing this division. So I will multiply both sides by 16. And now I'm going to need to use my calculator. So I'm going to say the sine of b is, 16 times the sine of 30, which is 1/2. So 16 times 30 is 8. 8 divided by 7 is 1.14. So the sine of b is 1.14. No, it's not. So the sine of b is not 1.14 because the biggest that sine ever will be is positive 1, and that's at pi over 2 radians. Sine will never be 1.14, and I can really make sure that I'm hammering this home by saying if I take the inverse sine of that, well, guess what? It doesn't work. You can't take the inverse sine of something bigger than 1 because, again, sine is not bigger than 1. So why is this happening? This is no solution. This triangle is impossible. You can't draw this triangle. The reason why you can't draw this triangle has to do with the minimum length of this altitude right here. This altitude, I'm going to do this in green, has to be a certain height for this triangle to be even possible to be drawn. I'm going to say the sine of 30 is h over 16. So I'm pretending for a second that this was a right triangle that I just created. I'm dropping an altitude and creating a right triangle. And I'm going to find the height of that triangle using my calculator, which will then say 16 times the sine of 30, which, remember, the sine of 30 is 1/2, so 16 times 30 is 8. 8. Okay. So h is 8. What that means is this height needs to be a minimum of 8 for you to even be able to draw a triangle. Because if you draw straight down, that's the shortest distance between these 2 points, is if I go 8 units. So if you look at what I've got right here, you've got some kind of bogus, stupid triangle where the hypotenuse is shorter than one of the legs. This is impossible. So they can't give you this information. You would have to say, look, A has to be 8 for me to even be able to form a triangle. If you make it a little bit bigger than 8, then maybe I can create more than one triangle, or we could talk about other stuff. But if A is not at least 8, I can't do this at all. So this is no solution. There is no triangle that fits this criteria. You can't find angle B because it doesn't exist. That's a no solution example where the leg that they give you is too short. What else can happen? Let's draw another triangle. And we'll now say, all right, we're talking about 30 degrees again. So this is 30. I'm going to do ABC the same way. Little a is 10, little b is 16. So again, you look at it and you're like, hey, angle side side. Better be careful. We'll write our equation. The sine of 30 over 10 is the sine of b over 16. And now to solve that for the sine of b, I will multiply both sides by 16. So 16 times the sine of 30, 8. 8 divided by 10, 0.8. Sine of b is 0.8. Now, the sine of b can be 0.8, but let me kind of try and convince you here on the unit circle that there's more than one answer. So the sine of b, remember, sine is the y value, and you're telling me that this height is 0.8. And if you think about it's part of the unit circle, this would be at 0, 1, and we're somewhere in here. I can find this reference angle pretty easily by doing inverse sine. So if I take the inverse sine, I gotta do it here. Inverse sine of 0.8, I get 53.1. So B is 53.1. At least the reference angle is 53.1. It's possible that we're actually in the second quadrant and the reference angle being 53, that's 53, can help us find this guy. And that will always be supplementary. They have to add to 180. So I'm going to do 180 minus 53.1. And we'll just see if this is possible. 126.9. So maybe B also equals 126.9, or it's the other one. We don't know which one of those two it is. Is it possible to be 126? If I made this guy 126 and this guy was 30, you added 30, you get 156.9. That's definitely less than 180, which means this is possible to draw. And the way it would look is if you took this is 10, right? If you took that 10 and instead of bumping it out this way, which is what they did, if you took that 10 and you bumped it in this way like that, then you would form the other triangle. And this angle right there is your new angle B, and it's 126.9. So we're really in a situation where we don't know if it's this triangle that they're talking about or if it's this triangle that we're talking about. And that's why we call this the ambiguous case, because ambiguous means, you know, like we're not sure. We can't really narrow it down here. It could be either one. But I think it's important you understand what these two triangles share. First of all, angle A in both of them is 30 degrees. This length in both of them is 16. And then this is 10 in both of them. Okay? This is an isosceles triangle. Essentially, you're taking this 10, this length right here, and instead of going out to the right, you're bringing it in going to the left, and you're drawing the triangle differently. And that will happen anytime you pick a length bigger than this minimum. So you could do the sine of 30 over 16. Bigger than that minimum, which I think in the other problem we said it was 8. Yeah. Bigger than 8, but less than what would form an isosceles triangle. So anything between 8 and 16 will give you two triangles. If you get to 16, you're only going to get one triangle. But in this problem, 10 is between 8 and 16, so we will get two different triangles. You can find the minimum height by doing right triangle trig, and then you can find sort of the maximum height where it will give you two answers right here. It's the other leg. So there's two answers to this, and you need to give me both of these. And eventually we'll probably also go back and solve all the other stuff, because here we had one of our angle B's was 53.1, and here the angle B was 126.9. So we could use these two and pretty easily find angle C and little c, which we'll do at some point, but not right now. Okay? So that's your two triangle case. That's your ambiguous case. Last thing, we draw this picture. So we have 30 degrees again. A, B, C. A is 20. C is 16. Okay, well this one's oriented slightly differently. That's okay. It's not that big a deal. We're going to do the same thing though. Sine of 30 over 20 is, now in this case, we don't know anything about side B, so we have to do it with side C. We'll do sine of C over 16. And now I will find the sine of C by multiplying both sides by 16. So 16 times the sine of 30. Remember, sine of 30 is 1/2. Half of 16 is 8. So 8 divided by 20 is 40.4. There you go, 0.4. So the sine of C is 0.4. And now when I do the inverse sine, I will actually find what angle C is. 23 let's just say 23.6. So angle C is 23.6. Now we're going to try and see if I can create two triangles again. And oops, the way I do that is I'm going to now subtract from 180. So 180, where's my calculator? That's not my calculator. 180. I stole my examples from that website though. 23.6. 156.4. So we can say that C is 23.6, or we're going to just check to see, well, it's 23.6, or is it 156.4? And the reason I know that it's not 156.4 is because if you add this to 30, you get 186, which is bigger than 180. And we know the angles of a triangle have to add up to less than 180. So that doesn't actually work. It's got to be that one. And that means that I can find this missing angle B. And to do that, I would do 180 minus 23.6. And then I'll also subtract the 30 that they gave me. And I'll find that this is 126.4. So you can see my triangle is very much not to scale. It would actually look more like, let's see, it's obtuse. So it would look more like this. A, B, C. It doesn't matter if you draw the picture to scale when you are sketching it, but I think it's nice to be able to say, hey, what should it look like? It should look like this, 16, 20. There you go. And now if it said find missing B, we could do that again using the law of sines. But this is the case where you only get one triangle. And that has to do with the fact that we picked a side that was in that sort of, it was too long. 20 is longer than 16. I think if it was an isosceles triangle, it would have looked like this. That would have been 16. So any of the range here, we could find that height right there and get any of the range here to tell you where it would be 2. But really, in this problem, there's only one triangle. But the idea is you're either going to have no triangles, and that's because you take the sine of B that is bigger than 1. That sine of B is never bigger than 1. And that happens when the altitude isn't long enough. Or you can get 2 triangles when the altitude is between, or I'm sorry, when your side length is between the altitude and what would form an isosceles triangle. So in this case, 10. 10 was between 8 and 16, so we get 2 triangles. Or in this problem, you only get 1 because 20 was bigger than 16, so it was bigger than that isosceles triangle. The algebra is usually pretty clear. It's sketching it that can sometimes be harder to figure out. But you always do the same thing. You find the inverse sine to get the angle, and then you check the supplement. So what you need to do now is on Schoology, you have a station assignment where there's 8 questions. You can work with other people, but every person needs to submit the assignment. So get that done, and you're good to go. Maybe hit that like and subscribe button on your way out, though.